Hi everyone, let's do a quick video on creating a quick generative AI application using RAG concept, Retrieval Augmented Generation. So this is basically when you want to do your own application to do a Q&A on private documents. So the problem is large language models like GPT or Gemini, Claude, they are trained on the data that's available on the internet, but you would want the same LLM capability on your private documentation. So one way is to fine tune these applications, but it is much more standard and preferred to have the LLM model extensible by some frameworks and open source applications. So the key tools which we will be using are LangChain, which is a Python framework, and it is mainly used to create chunks of the documents that it has been given, and to create the chains which where it enables it to basically do the LLM wrapping in the components and then sequence them where the output of one chain could be given as the input of the another to perform logical sequencing, and also agents where these chains can now interact with third-party applications to perform a specific task. Pinecone and a few others like Chroma, they are high performance vector search databases, and they basically store the vector embeddings of the text documents that have been given. LLMs, as we all know, these are deep learning models. They are trained on vast amounts of data. They are capable of conversing in natural language, and they are ideal for generating the embeddings of a given text. Streamlit is for demonstrating a quick and dirty application which is built with generative AI, and it can be rapidly deployed, and it's the perfect front end to build the Q&A. However, if this is a production based application, I would ideally expect this to be a mobile application where you would have the front end as Android and iOS, and via the REST APIs, you would expose the entire backend, which has the functionality of chunking, embedding, and searching a given input, a given query from the user's private documents. So let's quickly go through the logical flow of how actually the whole retrieval augmentation works. The step one is basically you need to store the document details, where Streamlit provides you the UI and LangChain creates these document chunks, and then any LLM, example GPT-4, whichever is providing an API to be used in software development, they basically create the vector embeddings, and the vector database stores these vector embeddings inside its database in the form of indexes. Now, what happens when the user has a query that needs to be answered? Streamlit takes the UI input for the user's query in a natural language, and then the control is completely with LangChain, which basically creates a chain sequence. And first, it sends the query to the LLM to get the vector embeddings of the query, and using the vector embeddings it invokes the Pinecone and asks it to do a similarity search, compare it to all the vector embeddings of the private documents it has stored in step 1. So it basically searches the vector embedding stored in step 1, and it basically results the returns back to the LangChain. LangChain then sends the vector embeddings of the query and the results both to the LLM, which then converts this into the natural language, which is understood by the user, which is then pushed via the Streamlit to show the response to the user. Let's see a very quick demo of this. So this is how the Streamlit application looks like. And if we are going to upload a document, so once we upload a document, so it basically gives you a clean, simple UI for the user to interact with. And here we are telling the user that we are reading. Chunking is basically converting into um, small pieces of the document. Embedding is creating vector of the small uh, pieces of the document. So here, when once we get this information, it is the information is now available here, and the trigger now is the UI input for the natural language, and LangChain will start triggering the chain sequence. So I will ask here, is the ending of the story sad? So I'm specifically expecting LangChain to answer from the document I have uploaded, and it is saying that the end of the story seems to be sad. So this is how it looks to the user, but in the backend, this is extremely fast. This involves the similarity search done by Pinecone, the to and fro which is done by the LangChain, and the natural language to vector conversions done by the LLM, and then the result is pushed back to the end user. So let's also take a quick look at the Python code, which basically enables this functionality. So we would import Streamlit, we would also import the embeddings library, and import Chroma, which is similar to Pinecone as a vector database. And these are all the document definitions where you would load these documents, and then you are chunking the document using the recursive character text splitter library. And using the open AI, and the text embedding model is text embedding 3 small, you would create the embeddings. Embeddings are nothing but the vectors, and this is the definition where this is the key thing where LangChain is basically creating the chains called retrieval QA, and the LLM model we are using is the GPT 3.5 Turbo. So here you can see it's doing a similarity search, and after we get the results of the similarity search, they are passed to the retriever, and the whole chain is invoked via the invoke function. And so once these function definitions are done, from here this is where we are actually creating the Streamlit UI, and where we give these widgets to upload the file, and then we are telling that we are reading chunking and embedding, and then we take the question here and basically ask a question, and once the answer is ready, the answer is displayed back in the text widget that is available to the user. So guys, to summarize, if you want to extend the functionality of LLM for your private documents and create a Q&A, this is a very efficient and fast way to augment the capabilities of LLMs, and it also makes us to replace the LLMs or the vector databases easier, because the flow control is basically in the hands of LangChain, and we are not binding ourselves to a particular model of the LLM. And instead of closed source, we could also use open source LLMs, or we could replace the vector databases as we see fit. So thank you so much and have a good day.